All right, today we're doing a deep dive into the technology behind a voice-powered job portal built for millions of blue-collar workers in India. This is a great story about some incredible challenges, some really clever engineering, and a huge architectural shift that honestly changed the entire game. So let's just start with the central question, because this really frames everything. How do you build an AI that can understand a plumber on a noisy street somewhere in India? We're not talking about a quiet office or a perfect recording. We're talking about real-world chaos and building an AI that can actually cut through all that noise. So who exactly are we building this for? The user base itself presents this massive set of technical hurdles. This is not your typical tech-savvy person. And this quote right here, it just gets right to the heart of it. We're talking about people who might be using a smartphone for the very first time. They speak in regional dialects, or they code switch into Hinglish, that mix of Hindi and English. For a lot of these folks, voice isn't just a nice-to-have feature, it is the only way they can interact with a digital service. And what's really wild is how these challenges all stack on top of each other. It's like a perfect storm. You've got extreme background noise, traffic, construction sites, noisy kitchens. You've got dozens of different regional dialects and people mixing languages. And then the hardware itself. We're talking about low-cost smartphones with pretty poor quality microphones. Any one of these things would be a tough problem to solve. All of them together, it makes building a reliable voice AI incredibly difficult. So how did the team even begin to tackle this? Let's take a look at their first attempt, the first-generation architecture, which was, it was ambitious and pretty clever. The initial idea was, hey, let's not bet on a single AI model. Instead, they decided to combine the power of two of the best systems out there. Bhashini, which is a government-backed Indian language platform, and Whisper, OpenAI's really powerful multilingual model. The goal here was to cover all the bases, right? Maximize your accuracy by sending a user's request to whichever engine was best for that specific job. And here's what that looked like in practice. The audio comes in, it gets hit with some heavy pre-processing and noise reduction, and then you get to this really critical third step, some complex routing logic that has to decide, okay, do we send this to Bhashini or do we send it to our self-hosted Whisper model? This created a ton of engineering overhead. It was powerful for sure, but man, was it complicated to build and maintain. But then, a new player comes onto the scene offering a totally different approach that promised to simplify, everything. And this is where the story gets really interesting. And this is Sarvam AI. Just think of it as an all-in-one solution. So instead of trying to patch together different services for speech-to-text and text-to-speech, Sarvam gives you a single unified stack. And the most important part? Its models are trained from the ground up, specifically on Indian languages, accents, and unique speech patterns. So here is the key insight. Sarvam's models are superstars in exactly the conditions where the users actually live. Low bandwidth, 8 kilohertz telephony audio. That's the quality you get on a normal phone call, not some high-fidelity studio recording. And in blind tests, it actually outperformed global leaders in these very specific, very challenging conditions. So this sets us up perfectly for the core of our explainer, a direct, data-driven showdown between the old, complex architecture and this new, unified Sarvam stack. This table gives us a fantastic high-level look, and you can see right across the board, from accuracy on that crucial telephony audio to the quality of the voice that speaks back to the user, Sarvam was a huge leap forward. But for me, the biggest wins are on the right side of that table: vendor complexity and real-time capability. Moving to a single vendor with one unified API, that is a massive simplification for any developer. Okay, let's dig into the hard data for the ASR, the automatic speech recognition. We're looking at word error rate, or WER. And just remember, for WER, lower is better. It means fewer mistakes. So you can see Sarvam's Saaras V3 model is right there, highly competitive with the best fine-tuned Whisper model, and it's significantly better than Bhashini, especially on that noisy audio. And it does all this with a single model, which means you get to throw out all that complex routing logic. Now let's talk about the voice coming back to the user, the text-to-speech side. This is a huge deal for the user experience. The older Bhashini system was fine, but it sounded like a computer, robotic. Sarvam's Bulbul V3 is totally different. It actually uses a large language model to look at the text and figure out how a human would say it, with natural pauses, the right emphasis, and a genuinely conversational tone. And the features for Bulbul V3 are really, really impressive. You get over 30 professional voices in 11 different languages.
A single voice can even switch between languages, like from Hindi to English, and keep the same voice identity, which is something Bhashini just couldn't do. And, once again, it's all optimized for that crucial 8 kHz telephony environment.
So the performance is clearly better. But the story doesn't stop there. The switch to Sarvam also unlocked some huge operational advantages. It just turns out that, well, simpler really is smarter. While the cost per API call might be pretty similar, the true value here isn't about saving pennies per minute. It's about getting rid of engineering headaches. A simpler architecture means your team can build faster, they can debug easier, and you only have one support channel to deal with when things inevitably go wrong.
And this chart just drives that point right home. The development overhead for that original v1.0 system was high. I mean, you're managing 2 different vendors, writing all this complicated logic, and dealing with 2 completely different sets of potential failures. With the v2.0 Sarvam stack, all that complexity, it just vanishes. It's one single, unified API. And yeah, there are direct cost savings too. A huge part of that old system was a powerful and very expensive GPU server that they needed to run the self-hosted Whisper model. By switching over to Sarvam's API, they could shut that entire server down. That's a saving of tens of thousands of rupees every single month. So, to wrap it all up, the move to the Sarvam stack was a win on literally every front. The architecture is way simpler, which makes development up to 50% faster. The whole system is more reliable, and what matters most, the end user gets a way better experience, with more accurate transcription and a voice that sounds much more human. And all of this kind of leaves us with one last big thought. This whole journey highlights a really fascinating question in the world of AI today. Is the best AI the one that gets the highest score on some generic academic benchmark? Or is the one that's perfectly optimized for a very specific, very difficult, real-world problem, like understanding a plumber on a noisy street in India? It's definitely something to think about.